Hello everyone, and once again you welcome back in a Cype Nepal, and hope everybody is fine. So today we have a came with a very wonderful topic, that is underground water tank. So how can we do the design and analysis of underground water tank by using a Cype software? We can do. So you can see the what is the dimensions and what is the requirements of client or as well as the site. You can see the length we have the 7 meter and width we have the 3 meter, and you can also see the cross section, and depth we have the 3 meter. So these are the dimensions which might be provided by the some client. So how these types of the structure can be designed and analysis by using a Cype software. And you can see also the structure detailings, and you can see these are the structure detailings of underground water tank. So each and everything we are going to explain you in this video, how these types of the structure can be designed and analyzed by the structural engineer. And you not only the underground water tank, sometimes we require to design the swimming pool also, and there is a similar process to design the swimming pool as well as the underground water tank. And sometimes we have the swimming pool below the ground, and sometimes we have the swimming pool at the roof level. So there is a similar process to design all these types of the structure. So you can see the image also, and these are the image, and this is the underground water tank image, and this is the image of the swimming pool, and this is also the image of the swimming pool at the roof level or top level we can see. So these are the, and you can see the so beautiful structure we have. How can we do the such types of the structure? So you can see these are the some of the popular swimming pool, and you can see we have the swimming pool here also. And so these are the structures of the swimming pool. So how these types of the structure can be designed and analysis by the structural engineer. So today we are going to see how these types of the structure can be designed and analysis by the structural engineer. So let us start by the software, and we also see how the bar bending schedule can be done. So all the things we are going to discuss in this video. So let us start by the software. So you at first we have to go for the Cype software, and you go to the Cype CAD and wait for some time. And here you have to go for a new, just you write the name of your project. And give the accept here. Beam model we don't have, so give the known here, and take the MPT project only. And give the accept here. Give the accept, and you will get the MPT one. And at first we have to start with the number of the floor, and give the accept here. Here I am going to take as a 3 meter as a project requirement. I have already told you that we have the 3 meter here depth. So here we have the 3 meter. So I am going to take here the 3 meter only. So 3 meter. And live load I am going to take as a 2 kilonewton, and dead load I am going to take as 1.5 kilonewton per meter square, and give the accept here. And you have to go to the edit the floor, and here you have to give the -3 meter to change the elevation. And you can see we have the water tank below the ground, and give the accept here. And you have to go to the beam definition here. So come to the beam definition, and here you have to go for the wall. And but you can, whatever you have the plan, you can import this plan in a Cype 3D. So you go to this option, edit the template view, and just you go to the new. Here you can select your plan, but I have saved in a desktop only, so I am going to select my plan, and this is my plan. Just give the open here, and give the accept, and give the accept. You will get the plan in a Cype. So just start with a wall, and just define a wall. Here you have to select the reinforcement concrete wall, and here you can give the what might be the dimensions, but I have taken the 0.3, that is a dimension of a wall, and 0.15 from the left and 0.15 from the right. And here we have to introduce the pressure diagram. But before that, I want to go for the some Excel sheet, and you can see this is an Excel sheet where I have calculated what is the pressure or what is the stress which is developed by the soil as well as developed by the water. So in this Excel sheet we are going to explain you how the pressure can be calculated. And you can see the underground water tank and the pressure diagram, as you can see. So how can we calculate it? Actually, you can see the dimension, the stress, and you can see in this side, the left side, you can see the stress due to the soil, and that is a stress due to the water. And I have considered that this is a P1 and this is a P2, and we have the formula, that is a Ka rho into H, and that is a Ka. Ka is actually the active earth pressure, and rho, that is the density of soil, and that and Ka give the that we can calculate the Ka, that is 1 minus sine phi and 1 plus sine phi, but actually the phi is the angle of internal friction. So all the things that you will get by the soil report, and some of the geotech, if you have in a site, they will give you the information, but if you put the formula, and you will get the 15.84, and that is I have considered 16 kilonewton per meter square. This is the stress which is developed by soil. In the same way, we have the right side, we have the stress due to the water, and you can see the P2, we have the formula rho W into H, and rho W is 10, that is a unit weight of water, and H we have the 3 meter. So you can see that we can calculate the what might be the pressure, and that is a P2, we have the 30 kilonewton per meter square. But if you calculate the net, because when the force acts on a structure from the opposite direction, it also balances some force by each other, and if you subtract this P2 minus P1, you will get the 14 kilonewton per meter square. That is a net force, and I think you might got, and this is a formula you will get in a geotech. If you have studied the geotech book, you will get this formula, and in this way we can calculate what is the stress which is developed by the soil, and what might be the stress which is developed by the water. And we have two cases we have to study. One case we have to study that when the tank is full of the water, then what might be the net force, that we have to study here. And in the similar way, we have the two cases we have to study. First one, when the tank is full of the water, and second one we have, and you can see we have the second case we have to study when the tank is empty. And same formula we are going to use here, that is we have get the 16 kilonewton per meter square. The same thing we have get here also, but we always go for the maximum stress. So I am going to take as maximum stress, that is from the right side we have the 16 kilonewton per meter square. This is a stress due to the water, and I am going to take as a 16 kilonewton per meter square, that we are going to get that the stress due to the soil. So same thing we are going to take by the software also. And so come to this Cype software, and here we have to introduce the pressure diagram. Just click there, and you have to give the pressure diagram name here, and just you go to soil pressure, and here we have to give just elevation. I have to change here just 0, and here you have to introduce the load, that I'm going to introduce the load, that is a 16, and I'm going to take as a 16. And you can see the EXCELL also, we have the 16 kilonewton per meter square. Same thing we have to take by the software also. Just you take the 16. If you have the water table also, you can introduce the water table, but I'm going to neglect this. because if you have the water table is defined as the level where the percentage of water is a maximum, that is a water table. This is a simple definition, but you if you require the more advanced, then you go for the Google, or you can go for the geotech book. You will get the what is the definition of a water tank. What is the definition, sorry, what is the definition of a water table. And just and again we have to introduce the force or a stress which is developed by the water. So you just click this generic pressure diagram. Here we have to create the one extra diagram here. So create the two elevation that I am going to take as -3 here, and we have to take as a 30 kilonewton per meter square. And you can see this is a pressure diagram. So just give the accept here, and just give the accept. Here you have to give the new here, but we have introduced the forces or pressure that from the left. We have this, and we have to give the new also, that is generic pressure, that is a right, that is a 30 kilonewton. And you can change the here we have to give the 0 only. So give the 0, and again you give the accept here, and you can see the what the pressure that acts on a valve. And same thing we have calculated by the EXCELL also, you can see here. And here we have the 16 kilonewton per meter square, and in this side we have a 13 kilonewton per meter square, that is the stress acts on a wall. And same thing we have done by the software also, and you can see the same thing we have done. Just you simply give the accept here, and here you have to select the without external fixity. Just you select this option, and here we have to give the depth, that is a 0.36. And here we have the what might be the soil also. You can give the, if you have the, here we have different types of the soil, and different types of the soil have the different SBC of the soil. So in this way we can select what might be the soil property as your site. But I'm going to take as a medium dense sand, or you can go for the gravel one also if you have silt or hard clay. If you have, then now I'm going to take as only dense sand here. So simply you give the accept here, and give the accept here, and give the accept here. Now you can on the snap, and here you have to active the only nearest one. So select this nearest one, give the accept here, and you can have the value. You can on the ortho, and we have the option for the extend. So you go to the wall, and here we have the extend option. Just you extend this, and just you extend this, and you have to delete. Just you go to the wall and delete, select the delete option, and select the extra, that is, and delete the selected wall segment in the group. Just you select the second option here, here you can see the what we have done. So we have to introduce the slab at the top. So you just go to the new, and here we are going to take as the dimension of the slab or depth of the slab, that is a 15 cm. Just you give the 15 cm here. You come to the down, here we have to give the that is the mat foundation. So we have to give here, and that is the dense sand I'm going to take here, and give the okay. But I am going to take as that is the 36 cm here depth, and give the accept here, and here you can give, and you can see in a 3D what we have done actually. And this is a underground water tank design. So at first, and we have to give the small opening at the top level also. So I'm going to give the opening here. Just you select this option, opening, introduce the opening here, and select here the rectangle, introduce the rectangle opening here, and select the non-structural beam and give the shape here. And you can of this ortho, and you can give the small opening here, and you can see in a 3D what we have done actually. And this is a model, that is a model we can create in a Cype. And then after we have to go for the analysis. Just you go for the analysis, you go to this analysis option and just select this and give the shape here and give the shape here. And in this way we can complete this our project, and you can check the deform shape. And we have already explained you how the deform shape, whether our structure is a shape in a deflection or not, you can see the very easily. And we have already told you how can we do. And you can see the contour map also. And here we have to go for and here you have to select the ground bearing pressure here also here by the maximum. And you can see we have the only 0.04 MPa, but if you go to the project general data, as in a foundations we have given that is 0.2. It means this whatever the SBC of the soil, this is higher than the we get from by the result. So our structure is safe in bearing also. And all the information you will get by the software. And you can go for this beam and just edit the wall here you can see the different. And if you want to change the reinforcements also, we have the option to change the reinforcement. Just I'm going to take as a 16 mm here. You can change the 16 mm, and here you can change the whatever. And here we have got the that the red mark, which means we have to change the some data here. Just I am going to take as a 15 here and 15 here and 15 here and 15 centi here. And here you have to give the that I am going to take as a 80 mm here, and here also I am going to take as a 15 centi, and that is a 15 centi. Just you accept this. And now you can see we don't have any red mark here. And so in this way, and also you can see the what might be the analysis reports also you will get. And forces also you will get what is a crack width also we can get here. And here we have two different options to get the what might be the total reflections in a structure also you will see. And different types of the reducing by the force, and the forces also you can see. And you can see the what is a horizontal forces and vertical forces, each and everything you will get by the software only. And displacements also you can see, and the displacement stress also you can see. And here the different vertical force and horizontal force also you can find here. And that is the forces also you will get. And you will get the principal stress also you can get here. And what is a compressor or tension in the wall also you will get. This all the red marks are the tension only. So in this way each and everything we can do by the software also, but also you can check the report also, and earth conditions we have to see. And you can see, and just wait sometimes you will get the report also. And you can see the what might be the reinforcement schedules also you can see. These are the reinforcement schedule, and simply you give the accept. But if you want to generate the drawing, just you go to the drawing option, and here you can check whatever you want. Just I am going to take as a layout that the 0, give the accept here. And I want to give the more details about the reinforcement concrete wall also you can do. But if you want to go for that is a reinforcement in a slab, and you can generate the whatever the data we require for the construction. Each and every details you will get, and you can see the all the reinforcement detail you will get here, how we have to provide the reinforcement. In this way we can do our project, that underground water tank, by using a Cype software we can complete our project. So this is a process to do in a Cype software, but I am going to introduce you the some Excel sheet and which helps you to create the bar bending schedule in a Cype. So just you open this two Excel sheet I am going to show you. And this is Excel sheet actually, and why we require sometime if you are doing the billing work and we have to submit the bar bending schedule to the client, at that time we have to do in a side, and this is a bar bending schedule actually we have done in a side, and you can see all the details. These are the bar bending schedule. So how the cutting length can be calculated and how the weight of the total steel we can calculate it. So if you go through the Excel, nearly it takes 4 to 5 hours to do this bar bending schedule. So but if you use some techniques or some of the Excel sheet, you will get the directly all the value which is a requirement in a site. So you can see this is Excel sheet, and this is Excel sheet where we can calculate the BBS very easily, and what might be the total weight of the steel we can calculate the very easily by using this Excel sheet. So I am going to take as a sum plan here. You can see and now you can see this is a reinforcement, that is a reinforcement where 8 number of the 12 mm have the 300 center to center, and total length is 7560 mm, and that is a length. And here also this is, you can see the details also which is given by the Cype, and you can see these are the details. So how to calculate the what is the total weight of the steel by using this Excel sheet. So you can see here we have the 8 number of a 12. So same thing we have to do by the Excel also. So you go to this Excel sheet, and here you at first you have to clear the sheet here, and you will get the information to clear the sheet. And here I am going to tell you about this Excel sheet, and you can see here we have the different how to cut the cutting length we can calculate, and here the many formula we have according to the BSS standard. You can see we have the different how to cutting length we can find, and you should not have to learn, only you have to see how the cutting length can be calculated. So all the things you will get here, and according to the BS and the British standard we will get here. So if you are working as a site engineer also we require these sheets. So we can do this, and you come to the next sheet here also. This is a details also you will get, and so you come to these sheets. So same thing I am going to do here, and you can see here we have the 8 number and 12 mm, and total length we have the 7560. So what is the total weight of this steel we can calculate the very easily by using this. So I am going to calculate here, just you select this here also, just only select this, and you will get the shape here. Just I am going to select this one, a straight one only. And you will get the message of this shape of this bar. Now you can do it. This is a number, you can give here the number, that is one number. Unit I am going to take as one only. and here we have the each one I'm going to consider. Total 8 number we have, and diameter, that is diameter we have the 12 mm, and just here you give the length we have 75-60 here, and you will get the total weight, that is 53 kg. And in the same way we have the different shape of the bar also we have, and you can this one we have completed. And here also you can see we have the 20 number or 21 number we have, and length is a 35-50 and 12 mm. So in the same way we can do in this Excel sheet also. Just you go to this Excel sheet, and here we can select this, and here we have to give the 2 number, and here we have to give the unit 1 and number, that is number in each layer we have the 1, and here we have the total you can select here. You can see the what we have the total 21 number, so I'm going to give here the 21 number, and here we have the 12 mm die, and here we can give the length, that is a 35-50, and you will get the total weight actually. And in this way we can do the different types of the bar bending schedule also. You will get here also the same process you will get, and not only only these types of the bar you can do the whatever the shape you have in a side also. Sometimes you will get this shape also, and the same thing we can do here also. Give the 1 number here, 1 number, and here we have the 10 number, and give the, that is the 8 number. Here we have the 3500, and just I'm going to take as a 50. So total weight you will get, not only this, and different types of the shape you can get here, and this stirrups also you can do. Just a 4 number, just I'm going to give the 1 here and 1, and that is the number I'm going to take as a 20, and just here the 8 number 8 mm I'm going to take, and you can give here, just I'm going to take as example, that is a 400, and B we have the 200 suppose, and I'm going to take as 100 mm. So simply you will get all the weights, and you can select the different shape from this Excel. And if you have, suppose you are working with a STR also, these types of the bar we have to cut. So what might be, there's just 5 number and 1 you can give here, and just I'm going to take as a 5 number we want, and that I'm going to take as 8 mm, and here you can give the dimensions. Just I'm going to take as and B I'm going to take as 1000 here, 1000, and C I'm going to take as 2500. So in this way we can calculate all the things, and all the BBS we can calculate, and we can get the total weight in a site. So in this way we can do our project, and we can easily find the BBS in a site by using this Excel sheet. So at last, thank you, we have explained you each and everything regarding the underground water tank, and sometimes also we will take the example of the swimming pool, how can we do. So all the things we are going to discuss, just you stay with us Cype family. We will discuss you all the projects, not only these types of the project, also we will get I think you see this project, and this is one of the top project and very famous building in the world, and you know how the twisting tower can be designed and analysis is done. So this is a beautiful concept we can get from the software. And you can see these are the building, and you can see this is a twisting building. And so how these types of the model we can analysis and design a site. And so we'll give you in the future we will also discuss you how these types of the structure can be designed and analysis or model in a Cype software. Each and everything we are going to discuss, not only the other project, and also such types of the project also you can do. And we have the design and analysis of a Burj Khalifa also. This is the tallest building in the world, and the height is nearest 830 meter, nearest 1 kilometer we can see. So how these types of the building can be designed and analysis. So all the things we are going to discuss with you in a future. And you can see here, this is a design and models I have done in a Cype, and this is a model. And the Burj Khalifa, as I think you might heard the name, this is one of the tallest building in the world, that is a Burj Khalifa, and height is 830 meter, nearest 1 kilometer we can see. So how these types of the also project we can model in a Cype, we are going to discuss with you in the future. So okay, thank you for watching and stay safe. Okay, thank you. So we'll meet you in the next video, and thank you, have a great time. Okay, bye.